Hello guys, my name is Craig and welcome to Peri Solutions. If you're new to my channel, please subscribe and hit the notification bell so that you don't miss out on any new videos. Today we're going to look at differentiating simple trigonometric functions of sine and cos. So firstly, there are general derivatives that we are required to know when differentiating trigonometric functions, specifically for sine and cos. So the first result that we have to know is that first result, d by dx of sine x is equal to cos x. Then the second one, we say d by dx of cos x is equal to minus sine x. Then the third one, right, such that after these two, such that the derivative of sine f of x, whereby f of x is any function of x, linear, quadratic, exponential, we say f prime x, this is now the chain rule, f prime x multiplied by the derivative of sine f of x, which is cos f of x. Then lastly, d by dx of the function cos f of x would be equal to minus, because we know after we differentiate cos we get a minus sign, so it will be now minus f prime x times sine f of x. So these are the quotable results that we're supposed to use and we're required to know. So now I would like to attempt the first three questions applying these quotable results. So the first one, the derivative of sine x minus cos x. So differentiating each term, we're saying the derivative of sine x is cos x. So let me say dy by dx. So the derivative of sine x is cos x, then minus the derivative of cos x is minus sine. So in brackets that will be minus sine x, such that the result is cos x plus sine x. Right. Then for the second part, we want to differentiate cos 1 over 6 pi minus 3x. So our f of x is the linear function 1 over 6 pi minus 3x. So we said that result would be dy by dx would be equal to minus f prime x. So f prime x being the derivative of 1 over 6 pi minus 3x. 1 over 6 pi is a constant. If we differentiate it, we get 0. So I say in brackets minus the derivative of 3x, we simply get a 3. So this is the f prime x. Then sine of f of x, that will be now sine of 1 over 6 pi minus 3x. And then we know minus times a minus will give us a plus. So the answer will be 3 sine 1 over 6 pi minus 3x. Okay, this is the result that we get for the second part. Now for the third part, allow me to write it here. Oh, okay, let me erase this part. For the third part, part C, we've got e to the power of x over sine x. So we want to find our dy by dx, but we see that this is a quotient, whereby our u is the numerator, e to the power of x, over v, the denominator sine x. And we say that dy by dx for the quotient u is given by v du by dx minus u dv by dx all over v squared. So u being sine x times du by dx, we say the derivative of e to the power of x is e to the power of x minus u, which is e to the power of x, times the derivative of v, which is, so the derivative of sine x, we say is cos x, all over, we put square brackets, so all over v squared being sine x being squared. So of course we can simplify that by factoring out e to the power of x. So we can factor out e to the power of x to get sine x minus cos x. Then this would be over sine squared x. Like that. Yeah. So that will be over sine squared x. So this is the result that we get for the paired part. Okay, so now we want to look at how we would differentiate, because if we take a look at these examples, these were just multiples of trig functions. So there are also situations whereby we'll be asked to differentiate powers of trig functions, sine to the power of 3x, cos to the power of 3x. So it cos to the power of 3 theta. So now we'd like to look at how we differentiate powers of trig functions. Okay, so as well we can come up with quotable results, whereby we're saying that, where should I put them? Okay, then we write them here. So d by dx of cos to the power of n of x, right? We get where n is any number, n being 0, 1, 2 to represent the power of the trig function. So we say this result will give us minus n, right, cos of n minus 1x times the derivative of cos x sine x. So the derivative of cos x is what? Is minus sine x. So this, we've applied the chain rule. Then the second quotable result for sine, this is now for sine x, d by dx of sine to the power of n of x. We're saying n sine to the power of n minus 1 of x times cos x. So as well, there we've used what? We've used the chain rule. So these, all of these are quotable results when differentiating trigonometric functions of sine and cos. So now looking at example D. Example D, we want to differentiate ln of sine x, of sine to the power of 3 of x. So now this, we said, if we had to put brackets here, this is a natural logarithm, and we said to differentiate ln of f of x. F of x being sine to the power of 3 of x, we said we get what? We would write it as dy by dx would be f prime x over f of x. Okay, so now we say that f prime x is the derivative of sine to the power of 3 of x, which is dropping the power 3, multiplying by sine, subtracting 1 from the power of 3, you get to the power of 2, times x, then the derivative of sine x, which is cos x. Then this is over f of x, which is sine to the power of 3 of x. And you know, sine squared over sine to the power of 3 of x, that will give us 3 cos x over sine x. Cos x over sine x being cot x. So this is the result that we get for that differentiation. Now let's move on to part E. So allow me to erase this part. Okay, moving on to part E, we want to differentiate x squared sine x. But we see that this is a product. So we use the product rule, this being u dot v. So dy by dx for the sine rule, sorry, for the product rule, we say that this would be u dv by dx plus v du by dx. like that. Okay, so now let's substitute. Our u is x squared times dv by dx. So the derivative of sine is cos x, then plus v, which is sine x, times the derivative of u, which is 2x. So now we can rewrite this as x squared cos x plus 2x sine x. Then now this would be the result that we get for that differentiation. Then I'm looking at the last part, which is f. Now this one, let me just put it below. So this was e. Then now we'll move on to f. So the derivative of cos to the power of 3 theta, we said d theta by, okay, let me call this dy by d theta, would be minus f prime x. Sorry. We're supposed to use this result. So minus, dropping the power 3, multiplying by cos, and then subtracting 1 from the power, we get it 2, multiply by theta, then sine of theta. So this is by the chain rule, right? Okay, so this was looking at just differentiating simple trigonometric functions. So please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.